Now we will consider another kind of fiber that we have started our discussion with, is a single mode fiber, right? For single mode fiber, the core diameter is very small, so that only one particular mode is supported. All the other modes, there is no chance to support other modes. Okay. The advantage of propagation of a single mode within optical fiber is that the signal dispersion caused by the delay differences between different modes in a multimode fiber may be avoided. Now, multimode step index fibers do not lend themselves to the propagation of a single mode due to the difficulties of maintaining single mode operation within the fiber when mode conversion, that is the coupling of modes, to other guided modes takes place at both input mismatch and fiber imperfections. So, for the transmission of a single mode, the fiber must be designed to allow propagation of only one mode, while all other modes are attenuated by leakage or absorption. So this may be achieved through choice of suitable normalized frequency for the fiber. For single mode operation, only the fundamental LP01 mode can exist. Hence, the limit of single mode operation depends on the lower limit of guided propagation for the LP11 mode. The cutoff normalized frequency for the LP11 mode in step index fibers occurs at Vc equal to 2.405. The V number, that means Vc means the critical V number. V number must be equal to 2.405 or less. Okay. So for a fiber with V number greater than 2.405 will never be a single mode. Okay, to achieve the single mode operation, the critical value of the V number is 2.405, and the fiber with a V number of less than 2.405 will be termed as single mode fiber. Okay, so 0 to 2.405 is the limit of the V number for the single mode fiber. Let us have one numerical problem. Estimate the maximum core diameter for an optical fiber with a relative refractive index difference 1.5% and core refractive index 1.48 in order that it may be suitable for single mode operation. It may be assumed that the fiber is operating at the wavelength 0.85 micrometer. Further, estimate the new maximum core diameter for single mode operation when the relative refractive index difference is reduced by a factor of 10. So from the expression of V number, we can determine the value of A. So A equal to V lambda by 2 pi n1 square root of twice delta. Everything is given. So it becomes 1.3 micrometer. Therefore, the maximum core diameter for single mode operation is 2.6 micrometer. This is the radius, so diameter will be 2.6 micrometer. Reducing the relative refractive index difference by a factor of 10, that will give us A equal to 4.0 micrometer. That means the diameter will be 8 micrometer. Okay, so as you can see that the relative index difference plays a very important role for the design of fiber, because it is very difficult to fabricate a fiber with such a tiny core. Okay, so instead of using this such index difference, we can use this index difference to get little bit higher core diameter so that we can fabricate the fiber easily. More on single mode fiber. In order to obtain single mode operation with maximum V number of 2.4, the single mode fiber must have a much smaller core diameter than the equivalent multi-mode step index fiber. However, it is possible to achieve single mode operation with a slightly larger core dia still much less than the diameter of multimode step index fiber by reducing the relative refractive index difference of the fiber. Practical values for single mode step index fiber designed for operation at a wavelength of 1.3 micrometer is of the order of delta equal to 0.3%. So it will give a diameter of nearly 8.5 micrometer. So both these factors create difficulties with single mode fibers. The small core dia pose problem with launching light into the fiber, and with field joining and the reduced refractive index difference present difficulties in the fiber fabrication process. Graded index fibers may also be designed for single mode operation, and some specialist fiber designed to adopt such non-step index profiles. However, it may be shown that the cutoff value of normalized frequency, that is the VC, to support a single mode in graded index fiber, it can be given in this way: VC equal to 2.405 into 1 plus 2 by alpha whole to the power half. So let us have a numerical problem. A graded index fiber with a parabolic refractive index profile core has a refractive index at the core axis of 1.5 and relative index difference of 1%. Estimate the maximum possible core dia which allows single mode operation at a wavelength of 1.3 micrometer. So normalized frequency V number can be written as 2.4 into 1 plus 2 by alpha whole to the power half. So it is 2.4 into root 2. So maximum chord radius that can be obtained using the expression for V number, we can get 3.3 micrometer. A equal to 3.3 micrometer. So maximum chord dia will be 6.6 micrometer.